Hi class, this is a quick explainer about how to set up your circuit for circuits that twinkle if you have any questions. You've made circuits in this before, so I'll assume you know how to drag pieces out and so on. What comes in handy on this and viewing is this little value key, just so you can see the values and make sure they're what they should be. So go ahead and click on that checkbox, and that way you can see everything. But I took some time before setting up this video to make the circuit so I didn't have to waste a lot of time. But just drag the pieces out, connect them with the wires, and once all the electrons are moving, you should be good. You can click each element to change the voltage. So if you wanted to change the voltage and see what would happen, you can do that by sliding that back and forth. Just click the battery for that. You can change the resistance of the light bulbs by clicking on the light bulb. Change the resistance like that. So those you have options for. I'd like everyone to start with 6 volts so we have something to talk about possibly later on. But you can change the resistance values anywhere between 2 and 8 ohms, I think is what the lab says. So just keep them to that range. Keep them in even increments. Like this does go to like 2.5 and something and stuff like that. But don't make it overly complicated. If you would like to mix this up a little bit, you can try a third branch if you want to add another light bulb to this. To see what happened with that, go for it. You can have up to 5 light bulbs. I'm just going to trash those. See some more functionality there. But you can have several branches. You could put 2 light bulbs on one of these branches and 1 on the other. You could put a second light bulb out here. Just keep it to 5 maximum light bulbs though. Okay. Now about measuring voltage, take this little voltmeter, and what this does is it compares the potential, the energy, at 2 points in the circuit. So if we put this on the same point, like on anywhere on the same wire here, I think we've got wire resistivity down to tiny. So there's very little resistance or 0 resistance in these wires. So you're not going to see any energy difference in the wires at all. But if you put one on one side of the battery and the other on the other side of the battery, you'll see 6 volts. So that's the value of voltage you're going to put down for the battery if your circuit looks like this. Now if you have this set up the same way, you'll put the probes across the light bulb. So you'll see that 2.4 volts is that light bulb, and you do the same thing across the other 2 light bulbs. Just put the black one on one side of the element and the red one on the other side, and you'll get the voltage that way. So you do that for every single light bulb. I don't want to give all the answers away here. Hopefully you're doing your own circuit, maybe making your own resistance values. That'll be a little bit more interesting than copying what I have. So that's the voltage. You can put that away when you're done. And to take out this ammeter, it's a little bit easier than the other one. In practice, real ammeters get hooked up like this. You don't have to do this at all. But real ammeters get hooked into the circuit like that. That's the difference between these. But I like the non-contact ammeter. This is just kind of like a virtual ammeter. Nothing really works like this, but we can inspect the current at different points. So to measure the current through each element, just put it on the element and you get the current through each one. Okay, and that's all you have to do with that. Once you have those values, it says to calculate the resistance and to calculate the power using those 2 formulas. V equals IR. You'll plug in the voltage, and R is the resistance. I is the current. So it's a strange letter for current, but that I represents current. I did mention in the last video that I'd talk about V equals IR. So let's see if that's working now. Switch over just a minute. All right, got my paper working here. So V equals IR is called Ohm's law. This is the voltage. You'll also hear it called potential difference. Because voltage makes sense for a battery, but voltage doesn't really make sense for a resistor. However, we can find the potential difference across a resistor, and that would be the voltage value. That equals current electrical current. Remember, that's the speed or the flow of electrons. And resistance. This is for a circuit like this. This is called a combination circuit. The resistance would be the equivalent resistance value of all those resistors together. And that's a lesson we're going to look at next. But that's how you'd use V equals IR to find current. To calculate resistance in this lab, you're going to rewrite this, divide both sides by I. So R is V divided by I, or the voltage, like 6 volts divided by the current. Or if it's the light bulb, it was like 2.4 volts divided by the current through that. So just take your measured values, plug them in here, plug them in there, and you'll solve for the resistance. And the last formula you're going to be using is for power, P equals IV. And again, you'll just plug in your measured current and your measured voltage and solve for the power value. Now power equates to the brightness. Okay, so the higher the power of a light bulb, the brighter it's going to be. All right, that's all I have to say about that. Or something, you know. I have to come up with a good line to draw these off with. It's kind of awkward when I don't really have anyone sitting there in front of me and, oh, babbling, sorry.